Hello students, welcome to series of lectures on digital speech processing. Now in this video you'll be able to learn the topic of introduction to the speech recognition, that is hidden Markov model. This is the first topic in unit number 4. Okay, now let's get started with this. So on completion of this lecture you'll be able to understand the hidden Markov model for the speech recognition. In the previous unit that we have already seen the speech recognition model. Okay, so what are the different steps we need to follow and what is the goal of the speech recognition and everything that we have already seen in the case of unit number 3. Now in this unit especially we are taking the acoustic model and language model. Okay, acoustic model with the help of the hidden Markov model process that we can do, and in this video you'll be able to learn some of the examples which are related to the speech recognition. Alright, so what do you mean by discrete Markov process? So first let us look at the functioning of a discrete time Markov process. So we need to consider the system that may be described at any time as being in one of the set of n distinct states. So at regularly spaced discrete time, the system undergoes a change of state according to a set of probabilities associated with the state. So now we are denoting the time instance associated with the state changes as t equal to 1, 2, and so on, and actual state at time t as qt. So the main important consideration we are looking for discrete Markov process is that, so in order to design any kind of the system, actually we are going to be representing that into the states, and we can assign the state transition probabilities. For example, if you look for 3 states, okay, so 3 states, state 1, state 2, state 3, and the state 1 to state 2, the transition probability is something like A12, and state 2 to state 3 something like A23, and similarly vice versa. Okay, so now we are going to be looking for the probabilities associated with the each and every state in the discrete Markov process. Now, so first order discrete Markov process is also called as a Markov chain, which depends upon the previous state only. This point is very important. Okay, this point is very important for us, because when you see the discrete Markov process, and especially for the first order discrete time Markov chain, which depends only on the previous state. Okay, now let us see this one. The probability of qt is equals to j. This qt is nothing but the current state. Okay, and for a given qt minus 1, this is the previous state. Okay, so probability of qt equal to j for a given qt minus 1 equal to I, comma qt minus 2, this is the another previous state we are taking, and so on up to. Okay, so this equation can be rewritten like this, because this discrete time Markov chain depends only on the previous immediate state only. So therefore, so we need to consider we are not going to be calculating all the probabilities of the past data. We are only estimating the probability of the current state with respect to the previous data. That's all. So probability of qt for a given qt minus 1, this is very important. Now the state transition probabilities aij is given by probability of qt equal to j for a given qt minus 1 equal to I. Okay, so this is a condition I comma j all are 1 to n. We need to consider n is the number of state. Okay, and with the following property. This property is also very important. Aij should be greater than or equal to 0 for all I comma j, and summation aij equal to 1. So when you want to represent all the state transition probabilities into the matrix, all the row probabilities will be, if you want to add, the row probabilities will be equated to 1. That is the meaning of this property. Now, so let us consider the n distinct states, that is S1, S2 and Sn. Okay, state number 1, 2, 3, so on up to Sn. N distinct states we have taken. So for our simplicity, I have considered only 5 states in it, if you want to visualize. So this is the way how we need to take the state diagram. So in this is A11, Aij, nothing but A11 for the state 1, and this is A21, the state transition probability from 1 to 2, and then from 1 to 5 like this. Okay, it will be easy. You can easily understand what is happening here. Okay, so total these are the time 1, 2, 3, 4, 5, and the states are representing by q1, 2, 3, 4 and 5. So what is the Markov property? We need to consider only the probability, the current state probability will be depends upon the previous state. Now let us take an example in order to understand better what is the discrete Markov process. So let me take the weather prediction example. This is the weather prediction. Once each day example is known, the weather is observed and classified as being one of the following. So state 1, that is a rainy, state 2 is a cloudy, state 3 is a sunny. Now with the state transition probability, this is capital A equal to these are. So this is I and this is J, for Aij. Okay. So A11, that is 0.4, this one. Okay. A12, 0.3, this one. A13, 0.3, from 1 to 3, where it is, this one. Okay. So if you add these three probabilities, will be equated to 1. We will be getting that as 1. Okay, 0.4 plus 0.3 plus 0.3 will be getting 1. And similarly, the second row also the same thing. Here also the same thing. Okay, so these are the state transition probabilities with the help of this model. Okay, I can call this is the statistical model. And in the further discussion, we are making this model to speech. Okay, how we are applying this model into the speech recognition. Okay, so to understand that, first let's look at the weather prediction example. So what is the problem here? The problem I have given with respect to the model is that, so given the weather on the day 1 is sunny, and then what is the probability according to the model given in the previous slide, that the weather for the next 7 days will be sunny, sunny, rainy, rainy, sunny, cloudy, sunny. Okay, so this is not the 7 days actually. You change this to 8 days. There is a mistake, and here one more sunny you need to include. Okay, this is state 3 sunny. Okay, 1, 2, 3, 4, 5, 6, 7, 8, total 8 days. So now first, in order to design, in order to get the probability, first we need to observe the observation sequence O. So this is observation because the first day is sunny. Okay, and what is the next 8 days he is asking. So this is the flow actually we are predicting S3. S3 is the sunny, sunny, sunny like this, and then this is S1 is a rainy, rainy, sunny, cloudy, and sunny. Okay, so this is the observation sequence. Now we want to calculate the probability of observation for a given model. So the probability of observation for a given model is nothing but it is a multiplication of all the probabilities. I clearly mentioned the discrete Markov process will depends upon the previous state probability. So this is the formula you need to remember. So pi is nothing but the product of each and everything, t equal to 1 to n, how many number of states it has. Probability of qt for a given qt minus 1. Alright, the solution is that, so probability of S3, these are nothing but the observation sequence for a given model. So initially we need to consider this as the initial probability, that we need to consider probability of S3 into probability of S3 for a given S3, this one, and similarly probability of S3 for a given S3. So therefore we have taken directly probability of S3 for a given S3 whole square. Okay, so we are multiplying with the same probabilities, and then into probability of S1 for a given S3 and S1 for a given S1, S3 for a given S1. This is a sequence actually we need to consider. Okay, so these many probabilities we are multiplying, and make sure that the first initial probability is probability of S3 in this example. Okay, and this initial probability is not given in the problem, so directly I can consider this as a pi 3 because it belongs to state 3. This pi 3 is nothing but 1 because they have not mentioned in the problem. If they mention that as some 1 by 3 or whatever, then you can take that value into the consideration. But in this example that is not mentioned, so directly you can take that as a 1. Now you multiply all the state transition probabilities, you will be getting the answer as this 1.536 into 10 to the power of minus 4. So what we have understood is that Markov model is the process in which each state corresponds to a deterministically observable event, and hence the output of any given state is not random. Okay, so we are not dealing the concept of the HMM. HMM nothing but hidden Markov model. So for now we are only taking an example with respect to the discrete Markov process. That means all the states are observable. There is no hidden state is available in this example. So hence Markov model are too restricted to be applicable to many practical problems, including the speech recognition. So there we are choosing the problem concept of the HMM. Thank you student. Thank you for watching this video.